We're going to do an optimization problem involving a hiker who starts at a point P and walks east towards point Q, which is on the road and 3 kilometers from point P. So from P to Q is 3 kilometers. The hiker will walk down the road for a while at a pace of 8 kilometers per hour. At some point between Z and P, or at some point Z between P and Q, the hiker is going to leave the road, so let's just put an arbitrary Z in here, and head towards a cabin in the woods that is directly north of point Q. Missed that line. 2 kilometers north of point Q is a cabin. So there's our cabin, and this here is 2 kilometers. So the hiker's going to go from P to Z and then Z to the cabin. So that's going to be his hike through the woods. Now what we need to think about is, first off, in order to minimize the time to go from P to Z to the cabin, where should the hiker turn into the forest? So what is it we're trying to minimize? We're trying to minimize the time. So we need to get a function of time. Well, there's quite a few things we don't know in this problem just yet. First off, I don't know the distance from P to Z, so I'm going to label that X. And I also don't know the distance from Z to the cabin, so I'm going to label that Y. Now, one of the interesting so let's start to set up an equation. Now, we're all familiar with the equation that distance equals rate times time. Well, what we're going to do is we're going to look at the time to go from P to Z, and we're going to look at the time to go from Z to the cabin. So we got 2 separate times here. Well, in rearranging this, divide both sides by R. Time is given by distance over rate. So as we start to build our function, first off, my time from P to Z is going to be my distance from P to Z, which I've called X, it's an unknown, over my rate from P to Z, which we were told is 8 kilometers per hour. Now we are going to add to that our distance from Z to the cabin, which is Y, over our rate from Z to the cabin, which is 3 kilometers per hour. So really what this is the time from P to Z, and this is the time from Z to the cabin. Now, this is nice, but we have an X and a Y, so ideally we'd like to get Y in terms of X. Well, look at what Y is. It's the hypotenuse of a right triangle. We know that this side is 2, and we just need this side. Well, the whole thing is 3. This distance is X, so this distance right here is 3 minus X. So using the Pythagorean theorem, the hypotenuse squared equals 2 squared plus 3 minus X squared. And we'll solve that for Y, so Y equals square root of 2 squared plus 3 minus X, the quantity squared. Now, because we'll be dealing with this in a derivative, let's go ahead and simplify that as much as possible. The square root of, and you'll FOIL this out, it's not 9 minus X squared, okay? And then add the 4, you're going to get 13 minus 6x plus x squared. So I won't do all the work in this problem because it is a bit of a long problem. So rewriting this all in terms of x, we know we had the x over 8 plus square root of 13 minus 6x plus x squared all over 3. Now what I'm going to decide to do here is I'm going to write this all over a common denominator of 24. You don't have to do this, but I decided to do this because I think it's going to make it a little easier, because that 1 over 24 is just a constant. So in finding the common denominator, what you're going to find is your numerator is going to be 3x plus 8 times the square root of 13 minus 6x plus x squared. So I'll leave you to figure out how to do that part. Okay, we now have a function we want to maximize or minimize, and notice x has to be between 0 and 3. So let's put that here. Can't be any smaller than 0, because why would we walk backwards first? And it can't be any larger than 3, because why would we pass this up and then walk to the cabin? So we are on a closed interval. So we're guaranteed to have an absolute maximum and an absolute minimum. So let's find our t prime. Now our derivative, the 1/24th, is just a constant. So I'm just going to write that out front and take the derivative of the numerator, which is 3 plus 8 halves, so making that a 1/2 power. This is a chain rule, times 13 minus 6x plus x squared to the negative 1/2. That's decreasing the power of 1 by 1. Now the second part of the chain rule times the derivative of the inside. Negative 6 plus 2x. Now, we need to figure out where this thing is 0. So I've got the 1/24th. And now inside my parentheses, what I have going on, I'm going to simplify a little bit. 3 plus 8 over 2 is 4. This is all going to the denominator. This square root of 13 minus 6x plus x squared. In the numerator, now I'm going to change the order on this. I've got 4 from the 8 halves, and I'm going to write this as 2x minus 6 instead of negative 6x plus 2. Or negative 6 plus 2x, excuse me. So that is going to get set equal to 0. Now the 1/24th isn't going to make a difference with the 0. So first thing I can do is I can move the 3 across, so minus 3 equals our fraction here, 4 times 2x minus 6 over the square root of 13 minus 6x plus x squared. And next thing I'll do, I'll cross multiply that radical. So I have minus 3 times square root of 13 minus 6x plus x squared equals 4 times 2x minus 6. And if you want to distribute that 4, that's fine. It's not going to change our final answer. And now I'm going to square both sides to get rid of this radical. Remember, that means you got to square everything. So negative 3 squared is 9 times 13 minus 6x plus x squared. And on the other side, again, everything gets squared. So 16 times 4x squared minus 24x plus 36. Okay. For time's sake, I'm going to combine a couple of steps. I've got a quadratic here. I need to get this quadratic equal to 0. So I'm distributing everything and combining all the like terms. You're going to get 55x squared minus 330x plus 459. All right, and in solving this with the quadratic formula, I get x is, I'm going to give it as a decimal, roughly about 2.191. Okay, now if I plug that into my original function right here, actually we probably plug it in here, I get that t is about 0.993, and the units, because our rates are in kilometers per hour, 0.993 hours. Now I also have to check my endpoints. X equals 0 gives a t of, if we plug 0 in here, that zeroes out, everything except for the rad 13. So 8 rad 13 over 24. It might be easier to compare if we have a decimal. So the decimal approximation of this is about 1.2 hours. And we got to check our other endpoint, x equals 3. The exact at x equals 3 is 25/24, which as a decimal, just going to 2 decimal points, it's enough to compare at 1.04 hours. So the quickest time that we could get there is for him to deviate through the woods at 2.191 kilometers from point P. So remember, all these are in kilometers. The maximum time is going to come if he walks straight to the cabin through the woods because he's walking at a slower pace, and it would have taken him approximately 1.2 hours.